case means that most of my experiences come out of the Amazon Web Services Cloud, and so please forgive me if I skip over some other clouds that are there. If you guys actually, can I have my slides back on? If you look at these slides actually, if you look at the picture, this is a proposal from MIT for a massive building just next to the 2012 Olympics. And that particular building is called the Cloud. Yeah? It is that you can actually cycle up, you can walk up, and there's all sorts of data and other information, video displayed about the games that are going on. And it's pretty impressive if you look at the proposal that they actually made. In reality, it's by now 2011, nothing has been built yet, so I guess this is one of those other clouds that are never going to materialize. Yeah. And of course, you really know that cloud is becoming cloud if Dilbert actually really starts making you the butt of the internet joke. Yeah, so there's something that I do every time. It's not because I'm actually wanting to redefine what cloud is, because in my eyes, cloud has nothing to do with technology. Well, there's some technology pieces, but in essence, and I really want to drill this into you folks, cloud is all defined by its benefits. Yeah, let's go back to that. It has to lower cost, eliminate capital, give you also operational lowering of cost for elasticity. But most important, often, customers will come on board in our cloud with a cost picture in mind. They will always claim, as soon as they actually have become familiar with the technology, with the way that they can use it, that actually increasing agility is the reason why they are really in the cloud. The fact that they are no longer constrained by server or storage resources, that they can actually move much faster in their time to market is way more important for them. Yeah? Removing heavy lifting, of course, it means that you're really using what is core competency and never, ever have to do those things again that actually do not differentiate you from any of your competitors or other people in the market. Yeah? And most importantly, one of the most important parts, and that's where actually I spend most of my time on today later on, is really that it is a foundation for building different architectures. And not just in terms of greenfield, but also in terms of using off-the-shelf components that we can actually build applications that are of much higher quality than that we could do before because of the cloud resources that are there. None of these state of the cloud, of course, or state of the AWS cloud goes without the kind of things that we've done in web services in the past year. This is only a summary, actually, of what we delivered in the past year. And the only thing that I can promise you for 2011, if I ever would get invited back again, is actually that next year I'll need 2 slides. Yeah. Why? I think we have this very close relationship with our customers, and each of our small business units, whether it's storage or email or compute, works closely together with their customers and is really working on improving their service relentlessly. And so whenever new features come out, whenever they have them ready, we do not wait for some big event to launch them all together. We release them immediately, because that was the moment when their customers can start benefiting from it immediately. This is by now how we look at things. You look at that, I'm actually moving away from this picture of a stack. I think this picture of a stack where you have infrastructure at the bottom, platforms on top of that, and another service on top of it, is actually just a model. It is really outdated. In essence, most of the whole Amazon cloud is much more than the Amazon services. It is a whole collection. It also has all services from all ecosystem providers as well. Yeah, so there's many different players, many in the ISV world, many coming out of the system integrator world and management world, that are adding so many different services into the Amazon ecosystem, that the cloud is much more and can no longer be defined by just having strict layers. Many applications will be pulling different services from different places and connecting them together. Yeah, so we're also now at 5 regions. Since last time we actually launched our Singapore region and we launched our Tokyo region. Yeah, very important, especially in terms of fault tolerance for many of our Japanese customers have become, since the unfortunate earthquake earlier this year in Japan, have become business continuity, and we see a large rise of actually using the Amazon Web Services with different availability zones to build survivable applications in the cloud, and using the Amazon Tokyo region for that. Of course, every year here I'm allowed to give you this particular slide. The idea is that the number of objects in Amazon S3 actually gives you some indication of how vast AWS is growing. Last year we were at slightly over 150 billion objects. We're now at 339 billion. So that is more than a duplication of the number of, doubling of the objects in S3. And in my eyes, we haven't even hit the need of the hockey stick yet. This is a new metric, sort of an indication how we're growing on a daily basis. On the compute side, we are adding each day as much capacity as that Amazon.com, the retailer, needed in the year 2000, where they were about a $2.7 billion company. Yesterday I gave a long talk about all the things that we did in the past year. It's often called the AWS Summit. If you want to go to that website, and all the slides are there, you can see a whole review of all the services that we built, the things that we launched in the past year, the kind of priorities we had, making it easier to use, driving cost and pricing down, launching new services, quite a few actually, one of them being Route 53, our DNS service. And so there's a whole weight of information there, not only from my talk, but actually from a lot of technical talks, whether it's on EMR or building highly available websites and things like that at that website. Yeah. Last year, again, we renewed our SS70 Type 2 audit, achieved 27001 certification. Many of these things are really important for our customers to be able to build on top of us, applications that are capable of achieving other levels of certification, such as HIPAA and others. It's important. I think these two documents, they have been renewed at the beginning of the year. One is the compliance document, and the other is the security document. Security document goes into detail in each of the services of Amazon with all of their security provisions. And the compliance document actually is a really detailed document on how Amazon is meeting the different compliance requirements. Yeah, actually, you don't need to read this. There's 34 common questions asked around compliance in that particular document with detailed answers. So if that's sort of looking backwards to in the past year, I want to come back actually what the original mission when we launched AWS was, which is to enable businesses and developers to be able to use web services to build scalable, sophisticated applications. That was 5-6 years ago when we launched this business. That was what we had in mind. With, of course, lots of things has happened in the past 5-6 years, and predicting the world of now from them, actually from that time, has been really hard. But there were some things actually, if I look back, especially with respect to sophisticated applications, has come through. And if there's one thing I want you to walk away with today, is that both developers and businesses, young businesses as well as enterprises, are building increasingly sophisticated applications in the cloud. Yeah, so what does that mean? I think in my eyes it has a number of properties: secure, scalable, reliable, fault tolerant, guaranteed performance, and efficient. So let's go through a number of these things to see how actually applications are being built. And young businesses, actually from the beginning, have been building very highly fault tolerant applications. This is one of our earlier customers actually on the website. It's Social is a company that does address book syncing. It's a very simple application, but as you can see, using multiple availability zones, using failover with respect to databases, multiple load balancers at the front end. And it's not that complex, actually. But they are able to survive a whole range of different kinds of failure scenarios because of this. And I think if you continue to look at fault tolerance, one thing that became really popular in the past years actually is this baby. Yeah? The Chaos Monkey was announced on a blog by Netflix, where basically they seen quite a few open source versions of the chaos monkey coming by to help people build much more sophisticated applications. And there's a whole center now at the AWS website, the Architecture Center, where we go into detail and give lots of best practices and help for customers to build this kind of highly reliable, fault-tolerant applications. And also we had quite a few technology pieces. This is the Amazon Relational Database Service. High on the list of the customers was to actually be able to use RDS in multiple availability zones so that you could actually fail over from one availability zone to the other in the case of certain failure scenarios. So we added our own replication protocol to this such that we could synchronous replication between two availability zones and allow customers to build very sophisticated, highly available applications. Often, of course, we hear then the criticism saying, yeah, but that's folks building stuff from scratch. Yeah, Netflix started from scratch. These young businesses start from scratch. It's all greenfield stuff. Yes, you can build these sophisticated applications if you start from scratch, but that's not how the enterprise world looks like. But actually, yeah, because most of the enterprise world is actually buying instead of building. But if you look at actually what the enterprises are doing, they are building equally sophisticated applications in the cloud. They're actually at this moment really last year being helped by the fact that both Oracle and SAP certified their software for production on the AWS cloud. This means that all of their software is for production supported by the original vendors. And this is pretty important. I think if you look at very simple solutions even, this is Oracle's e-business suite. It's very simple to run in two availability zones using DataGuard, using the Amazon load balancers, using backups into S3, and you can build a very highly available e-business environment without actually using any custom-made components. And it's even, some of the enterprises actually are going much further than it. Advanced Innovations is a supply chain company, a global supply chain company, and they have a very extensive architecture built completely out of off-the-shelf components. Yeah, so most of those components are actually either from Oracle or from Microsoft. And you see that they have a very, very extensive architecture. All of this, for 100%, runs in the AWS cloud. They're using multiple availability zones to build a highly available supply chain solution. And actually they are having this, they're using a very particular setup where their US customers are served out of a US region, in this case US East, and they back up that data into the European region. Meaning that if ever the complete east coast of the US would disappear off the map, their customers can still be served out of the EU region. And similar, their EU customers are served normally out of the EU region, but that's being backed up, again, using standard off-the-shelf components like DataGuard to actually back them up into US East, such that European customers, if Ireland disappears off the map, can actually be served out of the US. So standard components building highly available, very sophisticated solutions. And it's also the government, as a very large provider, and as a very large enterprise. This is one of the well-known websites that have launched in the past year, recovery.gov, but it's not just a simple website. It's actually built out of highly complex components. And so, you can get an overview of where all your data is being spent at a local level. And it is actually a collaboration between different very large enterprise providers, all running on top of the AWS cloud. So it's using Microsoft SharePoint, it's using S3's GIS product, and business objects from SAP to do the analysis. And I think this is sort of a pattern that I see more and more happening with enterprise software, especially on the cloud. So there's a cloud of enterprise services that are actually being connected together to provide additional value. And actually this is a pretty complex problem. And there's a number of companies that are already active in this space. And I would actually like to invite on stage Dylan from SnapLogic, who's going to talk a bit more about the solution that they have built.
Thank you, Werner. Pleasure to be at this conference with all you folks. We look at this environment, and as pointed out by some of the speakers earlier, we see this as the age of the business internet. Sort of a term that we use as a perennial term, and it's a term that has been there prior to us calling it, cloud, and just on demand, and et cetera, et cetera, et cetera. But what it means to us really is that there is a creation of value and an economic model around how people are absorbing technology, which is very much a mirror of what went on in the consumer internet in the latter part of the last century and the early part of this new century. We saw a revolution in the consumer internet. Now we're seeing a shadow of that, which I think is going to make anything that happened in prior client-server computing eras seem just small and insignificant by comparison. The work that we do at SnapLogic, and the reason we exist, is really to be able to provide a way to take this revolution to the next level. This is a phenomenal revolution. There has been a lot of progress. There's some incredibly bright, talented, well-funded companies, large and small, solving the technology pieces of it. And we think in addition to that, this revolution also has the other ingredient that revolutions need, which is there continues to be, even though there's a move towards the cloud, some of the business practices by some of the incumbent vendors in business continue to be somewhat heavy-handed, to put it mildly. So you're seeing smart companies move their business tasks onto the internet, the cloud. And as a result of that, what they want to do is they want to find a way to be able to do that in a manner that is connected, whether it's build or buy. They look at the world as a collection of web services, not as a stack. If somebody's buying Workday, chances are the HR department calls that the HR website. They don't think of it as an application, and that's exactly right. It's an aggregation of services that comes together to solve the overall business problem. And our mission at SnapLogic is to connect those services, or applications if you want to call them that, and to make them work in a unified manner. Put another way, for every $100 that somebody in business is spending on cloud computing, they set aside about $20 to configure, install, and connect the cloud. We want to provide the most value in connecting these applications and want to provide a lot of options for our customers and get them to market very quickly with the cloud, whether they're going from prem to cloud or between cloud applications, provide them that high level abstract view. So how do we do it? We made the bet on building new technology from the ground up that is built and works like the internet. Our core technology is built on a services RESTful manner. It executes anywhere. We've been on AWS since 2008. We're one of the first people in infrastructure to put our technology to work there. We've invented a abstraction, a container that lets us connect to pretty much any application, to pretty much any built or bought application without prejudice as to what language is programmed in. And this container is very much like a shipping container. In the same way the shipping containers have transformed the world of transportation. You can put a standardized shipping container on a boat, you can put it on a truck, you can put it on a train. In that same manner, SnapLogic has these abstract containers that we call snaps that provide an application neutral format for connecting things together. So you can go from application A to application B, and if you can go from A to B, you can go from B, C, D, E, F, J, and so on. Furthermore, mindful of the diversity of the cloud environment, we've also opened up the ability for these connectors, or snaps, to be built by third parties. We're getting close to about 100 snaps in our Snap Store. It's very similar to what Apple has done to the mobile computing marketplace, or to the mobile marketplace for the iPhone App Store. It's very similar to that for connection and integration. Check it out, store.snaplogic.com. About 100 today. We hope to have it about 1,000 with some help from folks in the audience here as we go forward. So who's using this stuff? We've been very blessed to have some thought leaders, companies like Canonical, Companies like Fusion.io, like Pandora. In fact, 2 of these 3 went public over the past 30 days and created billions of dollars of shareholder value for their customers. At Pandora, we are, in a sense, the information super hub that connects the various ways in which the revenues are produced through advertising, some through subscription, with their financial system, with Salesforce.com, of course, and a variety of other applications that are either built or bought. We have a nice mix of mid-market and enterprise customers. Enterprise customers include folks like Fox News and the Outback Steakhouse restaurant chain. Outback is a $3 billion restaurant chain that is bringing together a lot of information from its restaurants, pretty much all moving towards a cloud-based solution using SnapLogic. 1,600 restaurants, 80,000 employees at scale. Lots of data on orders, employees, HR, payroll, and a host of other internal systems. So we've been on a roll, and this stuff is going very well. So now just a minute about some of the things that we see going forward. What's very clear is that enterprises want the same level of connectivity that they get from applications on their data center or private cloud. They want these applications to talk to each other on a backplane. And we believe that the cloud is now ready to provide that kind of connectivity, that kind of interconnection, and we believe we are ready to do that. So we're thrilled to be partnering with Amazon. We're on our way to provide what we call elastic cloud integration, which is the way when you snap in something, you can kind of poke a hole at the snap level between those applications, and if they're all running on Amazon, boy, you start to get some of the round trips, and you start to get some of the very tight connection and integration that you could, in the past, only get on a private data center with a backplane, and we believe that is going to be something that's really going to bring the world of the cloud into the future. So we're excited to be here, and thank you, Werner, for the invitation to present.
Thank you. Thanks. Really cool technology. Yeah, I think these are, we know about the world of connected services, and we know about, that actually most architectures will be collections of services connected together. And I think the kind of things that SnapLogic is building are crucial components in the middle to actually connect these services together. It's really cool technology. Yeah? So if you think about, early on when it's talked about sophisticated applications, there's a whole range of different sort of attributes that I associate with them. But of course, efficiency is one part of it. And there's something that we launched about a year and a half ago. It's called spot pricing. So it's sort of the third different pricing model that we offer, where customers can actually bid for capacity, and if their bid is being met, actually their servers or their instances are being run. This has become very, very successful in terms of having architects think differently about, what is actually the cost that I'm willing to pay, what is actually the price that I'm willing to pay for completing a certain unit of work in a certain amount of time. And if you look at the architectures that they're building, that's, again, pretty amazing. The things that we've seen in the past year, just driven by Spot, is incredible. Yeah? And these are sort of, in my eyes, 4 large different architectures that we see making use of Spot. So on one hand, there's the MapReduce style operation, where you have a master controller and you're driving the computation. There's the grid controller architecture. Maybe some of those are actually commercial off-the-shelf grid architectures, grid controllers that can use these Spot architectures. Queue is an obvious one. Yeah, you put lots of work in the queue. You bid for units to work. If the workers actually are being spun off, they go to the queue, take units of work. For example, video conversion, start the video conversion. If it doesn't complete, the unit goes back onto the queue, and the next worker can actually pick it up. And then, of course, traditional checkpoint restore architectures where especially longer running computations do frequent checkpoints, and if then the computation is halted because the spot price is actually rising, when you can restart, you can actually return the checkpoint and can continue there again. A whole range of different customers using this, enterprises as well as younger businesses, and there's a whole range of different type of architectures, of different type of use cases. Quite some in the financial space, quite a few HPC, video processing is a well-known one, and in the AWS Summit that we did in New York, the guys from Vimeo gave a wonderful presentation on this, because some of our customers have extremely sophisticated bidding strategies. Yeah, and where, for example, for certain customers, they want to do high quality video transcoding with a particular SLA on them, because they're actually paying customers. But for other customers in the free tier, they may actually want to drop the price, and so they do very competitive bidding to actually run the video conversions at that level. Most of these customers are actually, and there's quite a few use cases on the AWS website, you should read them. Their bidding strategies are fascinating. And really making sure that they can get the lowest possible price for the kind of computation that they want to run. And one of the most asked combinations in the past months has been to combine Amazon Elastic MapReduce together with Spot. And so I think today we're happy to announce the availability that you can use EMR together with Spot in pretty sophisticated architectures, whether you want to run completely on Spot instances, or whether you want to have a number of nodes actually running on demand, for example, those providing the HFS file system, but your compute nodes running in Spot. Many of these new architectures are now available for the combination of EMR and Spot. Another thing that drives a lot of new efficiencies is actually new computer architectures. And many folks already knew that GPUs, graphic processing units, would actually be sort of the next generation of architectures that would power HPC computing. If you look at the top 500 list of supercomputing, I think the top 20 of them are now all combinations between high performance compute CPUs combined with these general purpose GPUs. So we introduced this in the last year as well, and we see again a whole range of new architectures arriving. So with many of our customers actually getting serious cost reductions because of the great speed ups that they're able to get. So Animoto, one of the darlings of the cloud from the early days, actually moved most of their high definition video processing from traditional servers onto the GPU servers, and they saw a reduction going from 6 minutes for a 30-second video back 6 minutes for a 30-second video to 45 seconds. Yeah? Which means that you can get instant gratification to your customers. They just only have to wait for the video to be immediately delivered to them, and actually at a fraction of the cost that it would take to run this in a generic infrastructure. So there was also a very important date last year, November 10, 2010. Guys, any idea what that was? On that day, actually 100% of Amazon AWS traffic was served out of AWS. Amazon.com is yet another customer on top of the AWS platform, a significant customer. But just like any other enterprise, it will take some time to move all of the components over to AWS. And so we were fortunate that November 10 last year, that at that moment, all the front-end fleet was actually in AWS. And from that point on, we started serving all traffic from Amazon.com out of AWS. For that, it was necessary that we actually changed, we went to a next generation of our virtual private cloud software. So the original idea behind virtual private cloud was that our customers would allow them to cut off a piece of the cloud, assign their own addressing block to it, run a VPN back to their own data center, and make their data center elastic. Where you would have full control over where the traffic in that particular piece of the cloud went. Mainly back over your own VPN and then out into the outside world. That was a good first step, but actually was pretty limited. So the next version of VPC that we launched earlier at the end of last year actually gives customer full control over all the pieces of the networking hardware and networking software. It allows them to set very complex ingress-outgress rules, to define private subnet, public subnet, netted address boxes in between, give you full control over which nodes can communicate with the internet, under which conditions, and who is allowed to make changes to all the different architectures. This was necessary for a large enterprise organization like Amazon.com to move most of its processing onto the cloud. So if we look at the coming year, I think there will be, there's not that many surprises in our priorities. I think many customers have asked us to actually expand the number of geographies, and we really have to focus on making it easier for you to actually use the existing services and actually add a number of, for example, database offerings, but also look at the let's say the governance pieces around it, which means, you know, make sure that billing and user management identity becomes easier, and actually make sure that we actually have more detailed and more choice in our support offerings. With that, as always, I'd like to end with that this is, you know, you've heard earlier on Lou and Joe talk about predicting for the next 10 years. I think that's a pretty difficult prediction to make. The only thing that I know is that almost on a yearly basis, we see the cloud evolving more. And we definitely see our customers evolving more and more and building more and more sophisticated applications that can actually meet the security requirements that they have, be fully fault-tolerant, scale over many different dimensions. And as such, it is still day one, because there's a lot of work to be done, and companies like SnapLogic are helping us with that. So with that, you know, thank you very much for your attention, and as always, you can connect to me on the internet everywhere. Thank you.